Hey, what's up guys, welcome back to this video. In this video we're going to solve a coding interview question, sort colors. In this problem you're given an array contains zeros, ones and twos, where 0, 1 and 2 represent the color red, white and blue respectively. Sort the array in ascending order. We have to solve this problem in constant space complexity and in single patch. Before we start solving this problem, first let's see the example, then we'll see the naive solution, then we'll slowly optimize the solution to single patch and constant space complexity. Now let's see some examples. For example, if you're given this array contains twos and zeros. Here we have 1 2 and 1 0. If we sort this array, we get this array. So if we're given this array, we have to return this array. For example, if we're given this array, in this array we have 2, 0 and 1. We have to sort this array. If we sort this array, we get 0, 1 and 2. So this is the ascending order. We have to return this array if we're given this array. For example, if we're given this array contains 2 twos, 2 zeros and 2 ones. If we're given this array, we have to return this array. Now let's see one more example. For example, if we're given this array contains 3 twos, 2 ones, 3 zeros. We have to sort this array in ascending order and we have to return this array. Now how we can solve this problem? First, let's see the naive solution. For naive solution or for brute force solution, we can solve this problem using merge sort algorithms. This merge sort algorithm will take O of n log n time complexity and O of n space complexity. If you don't know the merge sort algorithms, we have a video in this course in the section sorting algorithms. Was the video if you want to solve this problem using merge sort algorithms. Now let's see how we can solve this problem in constant space complexity. Then we'll see how we can solve this problem in single patch. For example, if we're given this array, first what we're going to do, we're going to count number of ones and number of zeros. We don't have to count number of twos. We can find out the number of twos if we know the number of zeros and number of ones. In this array, we see the number of zeros is 2. Number of ones in this array is 2. Now we know the number of zeros and number of ones. Now we can find out the number of twos. Let's see how we can find out number of twos. The length of this array is 6. So 6 minus zeros plus ones. That means the number of zeros plus number of ones, that is 4. So 6 minus 4 equals to 2. The number of twos in this array is 2. We can find out number of zeros and number of ones by scanning this array from left to right once. We'll see how we can find out that when we'll go through pseudocode. After finding out number of zeros and number of ones, what we'll do, we'll replace the first two element with 0. So let's replace the first two element with 0 because we have 2 zeros. So here we're going to replace this 2 with 0 and this 0, this is already 0. Also we will update this value with 0. Then we have ones. We have here 2 ones. So we're going to replace the next two element with ones. Here 1 and here 1. Then the rest element we're going to replace with 2. So let's replace this element with 2. Here let's replace this element with 2. This is the intuition of this problem. First we have to find out number of zeros and number of ones. And then we'll update our array with the number of zeros and number of ones and the rest with number of twos. This is how we can solve this problem. This solution will take big of n time complexity and big of 1 space complexity. Because we are just using two variables, zeros and ones. We're not using any additional space. Actually, this problem will take big of 2n time complexity because we have to scan the array once for finding out number of zeros and number of ones. Then we have to iterate this array from left to right to update the values with zeros, ones and twos. So the overall time complexity is big of 2n. And this is not a single pass algorithm, this is 2-pass algorithm. Now let's see pseudocode for this solution. This is the pseudocode. First we have this function sort colors. This function takes given array as input. Then we have here variables zeros and ones. We initialized these two variables with zeros. Then we have here loop for I from 0 to length of the array -1, and here we're using this loop to find out number of zeros and number of ones. Then we're running this loop from left to right to update the value. If I is less than zeros, here I is the index number and zeros is the number of zeros we have in the array. Else if we're checking if I is less than zeros plus ones, that means number of zeros plus number of ones. If this condition is true, we're updating the value with 1, else we're updating the value with 2. For example, if we're given this array's input, first we're going to find out number of zeros and number of ones. After execution of this for loop, we'll have zeros equals to 2 and ones equals to 2, because in this array we have 2 zeros and 2 ones. Then we're running this loop. We see 0 is less than 2, so let's update the value at first index with 0, then at the value at second index, that means at index 1 with 0. Then in the next iteration, we'll update this value with 1, then this value also with 1. This value is already 1, but we'll update. Then for the rest 2, we'll update this value with 2 using this statement nums_i equals to 2. So 2, 2. This solution takes big O of 2n time complexity, and that's big O of n, but this solution takes 2 paths, not single paths. Okay, this is 2 paths algorithm, and the space complexity is big O of 1. We solve this problem in constant space complexity and in linear time complexity, but this algorithm takes 2 paths because we have to scan the array twice. The constraint to this problem is that we have to solve this problem in single path and in constant space complexity. Now let's see how we can solve this problem in single path and in constant space complexity. For sake of understanding, let's assume we're given this array. To understand the single path algorithms, we're going to go through the intuition. To solve this problem, we're going to use 3 pointers. First, low pointer will point to the first element. High pointer will point to the last element. H for high, L for low. And we're going to initialize another pointer middle. Okay, this is middle pointer. We have low pointer, high pointer, and middle pointer. Initially, low and middle pointer point to the first element, and high pointer is pointing to the last element. Now, first, what we're going to do, we're going to check if the middle pointer points to 0. If the middle pointer points to the element 0, then we will swap middle and low. Okay, if middle pointer points to the element 0, we will swap middle and low, and we will move middle to the next and low to the next. If middle pointer points to 1, then we will just move middle pointer to the next element. If middle pointer points to the element 0, here let's say A for array. If middle pointer points to 0, we're going to swap middle and low pointer, and we're going to move middle and low pointer to the next element. If middle pointer points to the element 1, we're going to move middle pointer to the next element. If middle pointer points to the element 2, we're going to swap the element for middle pointer and high pointer, and we're going to move a high pointer to the left. Now let's see how this algorithm actually works. We see that middle pointer points to the element 2. So what we're going to do, we're going to swap the element at middle pointer and the element at high pointer. So let's swap 2 and this element 0. So 0 moves here and 2 moves here. We're doing this using this formula, and we're going to move high pointer to the previous element right over here. Now what are we going to do? We're going to check if middle pointer points to 0. We see middle pointer points to 0. So what are we going to do? We're going to swap the value at middle and low pointer. So here you have 0. If we swap 0 and 0, then we'll have here 0. And we're going to move middle to the next and low to the next. So let's move middle pointer right over here and low pointer right over here. Now what are we going to do? We're going to check, does middle pointer points to the element 0? Yes, we see middle pointer pointing to the element 0. So we're going to swap middle and low, that is 0. So nothing need to be done here. We have here already 0. We're going to move middle to the next and low to the next. So middle points to the element 2 and low points to the element 2. Now we're going to check, does middle pointer points to the element 0? No. Does middle pointer points to the element 1? No. does middle pointer is points to the element 2? Yes. So we're going to swap the value at high and value at middle pointer. So let's swap 2 and 1. So 1 move here and 2 move here. And then we're going to move high pointer to the left. High will point to this element. Now we're going to check, does the middle pointer points to 0? No, middle pointer points to 1. So this is false. If middle pointer points to 1, then we're going to just move middle pointer to the next element. So let's move middle to this element. Now we see middle pointer points to 1. We're going to move middle pointer again to the next element. Middle pointer will points to this element. We're going to apply this formula using a loop while middle is less than or equals to high. And here we see that middle is greater than high. So we're done. We'll just return the array. And we see that this array is sorted in ascending order. And we're iterating this array from left to right only once. So this is a single pass algorithms. We're solving this problem in linear time complexity by scanning this array once from left to right using 3 pointers. And it takes constant space complexity because here we're using 3 pointers, low, high, and middle. And we're scanning this array only once. So this is a single pass algorithm. So this is a single pass algorithm. Now let's see the pseudocode. This is the pseudocode for this problem. Sort color, this function takes the given array as input. Here we're finding out the length of this array. Then here we're declaring low and middle pointer, that is points to the first element. The index is 0. Then high pointer points to the last element, so n-1. While middle is less than or equals to high, we're going to apply this code. Okay, here if the middle pointer points to the element 0, then we're swapping the value at low and middle pointer. Then we're moving low and middle pointer to the next element. Else if we're checking if middle pointer points to the element 1, we're moving middle pointer to the next element. If this true condition is false, that means middle pointer is pointing to the element 2 because we have only 0s, 1s, and 2s in our array. If statement and else if statement evaluated false, that means our current element is 2. If current element is 2, we're swapping the value at middle and high pointer, and you're moving high to the left. Let's see how once more time. Let's say we're given this array. Low pointer points to this first element, high pointer points to this last element, and middle pointer points to this first element initially. We see middle pointer points to 2, so here we're going to swap 2 and 0, 2 and 0. So here 2 and here 0. We're swapping, and we're moving high pointer to the left. We see middle points to 0, so we're going to swap 0 and 0, that is 0. Then we're going to move low here and middle here. And we see middle pointer points to the element 0, so we're going to swap 0 and 0, that is 0. So let's move middle and low to the next element. Low point here and middle point here. Now we see middle pointer points to the element 2, so we're going to swap 2 and 1. So 1 move here and 2 move here, and we're going to move high to this element. Now we're going to check, does middle points to 0? No. Does middle points to 1? Yes. So let's move middle to the next element. Now we see middle points to 1 again, so let's move middle to the next element. Middle will point here. Now we see this while loop evaluated false. So we're done. Here we have modified this array in Fletch, so it takes constant space complexity and linear time complexity. And this is a single pass algorithm, okay? And that's what we're looking for. This is how we can solve this problem in linear time in constant space using single pass algorithm. Hope you have understood this video. If you have an issue understanding this video explanation, let us know. Thanks for watching this video. I'll see you in the next video.